Hi folks, we're going to take a look at an example of solving a rational equation. Okay, so here clearly we have a rational equation because there's a bunch of rational expressions, and our goal here is to turn this into a polynomial equation. Okay, and we do that by eliminating all the possible denominators. And the way we do that is similar to what you would have done when you had a bunch of denominators that were constants, is we're going to multiply both sides of the equation by the lowest common denominator here. So in order to do that, best thing to do is to factor any denominators that can be factored, and we see that this first one can. Okay, so x squared minus 3x minus 4, and if I factor that denominator, I get x squared times x minus 1. Okay, and then from here it's a lot easier to see what the lowest common denominator is. Okay, so here I've got an x squared, but I also have x squareds in these other two denominators, so I don't need to account for that more than once. So my LCD definitely will be x squared, and I see that I also need a factor of x minus 1. Okay, so now once I have my lowest common denominator, I multiply that to both sides of the equation. Notice how I always use brackets just to make sure that I'm multiplying it to everything on each side of the equation. That's particularly important if I have a term on one side that only has a constant in it. Okay, I might forget that I need to multiply that to both sides. So I just get used to always putting those brackets, okay, even if I don't really need them, since there's only one term here on that side of the equation. Okay, so once I do that, let's start with the left-hand side. I have to distribute this to each term, and when I multiply this to the first term, well, the x squared in the numerator and denominator, that's going to simplify, and the x minus 1 in the numerator and denominator will also simplify. So in the end, I'm just left with x squared minus 3x minus 4. Okay, so now let's multiply this to the second term in the bracket. Okay, so here the x squared in the numerator is going to simplify with the x squared in the denominator, so I've succeeded in getting rid of that denominator. This is where again I want you to be careful, because now I still have to multiply x minus 1 times 1. Okay, but I've got this subtraction here, so again please make sure anytime you've got a subtraction that you're putting the expression in brackets. Okay, if you don't put the brackets, you won't correctly interpret the signs on that second term. Okay, on the other side of the equation, again, the x squareds simplify. So I'm just left with multiplying x minus 2 times x minus 1, and so I might as well just do that right away. So that's x squared minus 3x plus 2. Okay, and now let's just solve this as a polynomial equation. So I do notice here that I have an x squared on either side of the equation, so I know those will cancel out, since if I bring x squared to the other side, I'll just get 0. Okay, I also notice that I've got the same thing going on with the minus 3x's, so we see that this quadratic equation turns out to be just a linear equation. So now let's finish this off. So I'm left with minus 4 minus x, and again the reason why we needed the brackets, because this is actually plus 1, and then we're just left with 2 on the other side of the equation. So I'll bring the x to the other side, make it positive, and here I'm left with negative 4 plus 1, negative 3, and then minus 2 from the other side, negative 5. Okay, and there's our answer. So in the end, the polynomial equation I had to solve turned out to be linear. Okay, now one thing that we should have probably mentioned at the very beginning is that I have some restrictions on this equation. I know this equation isn't valid for x equals 0, because that'll give me 0 in the denominator, or x is equal to 1. Okay, so it would have been a good idea here to specify that x couldn't be equal to 0 or 1. In the end, it has no effect on my answer. Okay, now this is not something I would suggest you do normally, just because it takes quite a while, but for this one example, let's actually test that that's indeed the answer we're looking for. Okay, so let's stick negative 5 into the original equation and make sure it satisfies it. Okay, so I'm going to do a lot of this in my head, so just follow along or use a calculator if you need to. So here we've got negative 5 squared, so 25, and this is minus 3 times negative 5, so that's going to be plus 15 minus 4 over Okay, let me stick it into here instead of there. I can even do this here. Negative 5 cubed is negative 125 minus negative 5 squared, so 25. So negative 125 minus 25, negative 150. Okay, and here minus 1 over 5 squared, so 1 over 25. And on the right hand side we've got negative 5 minus 2, negative 7 over negative 5 squared, which is 25. Okay, so we should put a question mark just to, because we still don't know yet that they are equal. And now let's simplify this left hand side. So we got 40 minus 4, 36, so negative 36 over 150 minus 1 over 25. So let's put everything, I'll just put everything over 150. I could simplify this, but it's just easier to put everything over 150. So minus, so 25 times 6 is 150. So this will be 6 over 150. So that's, oops, shouldn't have that equal sign since we still have, I'll put the equal signs here with the question marks because we're testing these. Okay, and so negative 6 minus 6, negative 42 over 150. And when we simplify that, well, these are both divisible by 6. So negative 7 over 150 divided by 6 is 25. So the equality is true. Okay, so again, this is not something I would normally do. It's just to test out that our method does make sense. Okay, so just to recap, when you've got a rational equation, your goal is to eliminate all the denominators, and you do that by multiplying both sides by the lowest common denominator. Okay, so in order to find that lowest common denominator, sometimes you have to do some factoring. Okay, anytime you have any subtractions, please be sure to use